Okay, always difficult. You set the sine function, and I want to point out, whatever these numbers are, the sine squared of n, looking at it, you're starting at 3, blah, 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 blah. I hope you realize the sine function looks like this. Well, that would be no good. But the sine squared function will look like this over here, if you square it. It's always going to be above the origin. It does have zeros, by the way. You should realize, though, the zeros occur at certain numbers. And what numbers do they occur at? Well, for the sine function, it's going to be multiples of pi. I'm never going to hit a multiple of pi for this. All right? It's just not going to happen. So I'm going to say, looking at this thing over here, let me erase this over here. I kind of convinced myself of this, that this thing here is always going to be greater than 0. So what do I know about this thing? I know it's a positive term series. Right? So what I'm going to do is get a comparison for you. And what I'm looking at over here, I hope you realize the sine squared function could never exceed 1. So I'm going to say an easy comparison over here would be 1 and n4 in the bottom. The question is, which one's bigger? Right? Which one's bigger? Well, this guy on the right side is bigger. And why is that? Well, the sine squared, right, is never going to exceed that. All right? Maybe put a little equal sign over there, too, because we could include it. It's not going to hit it, though, by the way. Maybe I shouldn't put that down. But you could. Right? You could say it's less than or equal to it. Now, what do I know? I know that comparison is whatever I get over here, n equals 3 to infinity, 1 over n4. What do I know about this over here? This is a convergent p-series. All right, let's look at the k. And yeah, we wrote that down, and the comparison we're using is 1 over n4, convergent p-series. We're good to go. Thank you.